Okay, greetings. Page 3. Let me describe the solid for what the heck? Oh, this goes back to the last problem. So I got to look at this. So it's describe the solid formed by rotating around the x-axis. X-axis is that way. So if I look at this, ooh, this is going to be a cool one because check it out. If I rotate it around the x-axis, this is going to reflect down here, and this is going to go there. 1, 2. So I'm just counting it's too wide. That's going to make a donut. See it? Donut with the hole. So I'm going to make a donut. But I'm going to draw it for a second just so I can see it. It's going to make it there and then there. Right there, right? Okay. Now, but look at this donut for a second. This inner radius is 1. Okay, so the inner radius is 1. And then the outer radius, the radius of the outer thing is 1, 2, 3. So from there to there, that's 3. Okay, so what's the volume of this? So it's going to make a donut there. Okay, cool. What's the volume? Well, the volume of this, remember, there are two ways to find volumes of things or areas of weird shapes. One is to find all the pieces and add them together. That's what we did on the previous problems back on page 2. This one's different. It's going to be far easier, rather than to break this into pieces, to find the area of the big cylinder, the outer one, and then subtract the whole. So the big cylinder, the cylinders are always volume equals base area times the height. And hopefully you've realized that the base area is pi r squared because it's a circle times the height. So the volume is going to be the area of the big thing. Oh, well, how long's the height on this? The height is 1, 2, 3, 4, 5, 6. Oh, you didn't see that. 1, 2, 3, 4, 5, 6. It's 6 height. 6 height. Okay, so the volume of the big cylinder is going to be the area of the base, which is the circle, pi times 3 squared. Okay, that's the area of this big circle there, times the height, which is 6, minus, so that's the big cylinder, minus the hole. Well, the hole is a small cylinder where it's pi times 1 squared, because that's the inner radius, times the height is the same. Okay, I'm going to type that in my calculator just like it looks. So pi, there it is, times 3 squared times 6, okay, minus pi times 1 squared times 6. Oops, I put h there. It should be a 6, right? 6. There we go. Now it's a 6. And I get 48 pi. 48 pi. Now, if you expressed that as the decimal 150.8, that's fine. Cool. Okay. Let's look at this. The population of Washington County is that many, and the area is this. What is its density? Well, density is density is equal to the amount of stuff, or the quantity, over the amount of space it takes. So in here, its population is 180,279. By the way, that's no longer accurate. That's over 2,426. And this is people over square miles. So if I type that in my calculator, 180,279 all over 2,426, I get 74.3. 74.3. And this is going to be people over square mile. Without the units, it is not correct. Always include your units when it has them. Anything like here. Okay, Fish Lake. Oh, that's a beautiful place. I'd like to go there soon. I'm sure there's ice up there still. Okay, Fish Lake has a water surface of 3.907 square miles. How many fish would you have to stock in the lake in order for the fish population density to be 550 fish per square mile? So the density is 550 fish over 1 square mile. So turn that density into a thing, and then I can set up a ratio. That equals 3.907 square miles, so 3.907 square miles, and I want to know x. Okay, see it? I'm using this same relationship, stuff over space or quantity over space, and the density is a ratio, and it sets it equal there. Now I can cross multiply. Multiply these, divide by 1, and I get 550 times 3.907. Yeah, that's right. Divided by 1 gets me that many. 2148.85. But if you stock 0.85 of a fish, that's kind of a mess. So I'm going to round that. I'm just going to put that to a whole number since I've got to do whole fish. 2,149. So 2149 fish. Okay? Okay. What is the volume of an 8.176 gram sample of pure silicone with a density of 2.3? So this is the same kind of problem. It's giving me a density 2.336 grams over 1 cubic centimeter. And it gives me a mass of 817.6 grams. And I want to know what's the volume. Now, this is a little bit different than the fish one up above in the sense that I'm still solving it, but I can actually have a decimal here because my volume could be a half a centimeter, half a cubic centimeter, things like that. So 817, but I set it up the same way. Take a cross product, 817.6 times 1, and I'm going to divide it by 2.336, gives me 350. Wow, that worked out to be really pretty. 350 cubic centimeters. Okay. Now, these are problems like the applications. A cylinder has a radius 2 feet shorter than 1/3 the height. Okay, so I got to visualize that. I've got a cylinder, and I've got a radius, and it says the radius is 2 feet shorter than 1/3 the height. That means this radius, 2 feet shorter, I'm subtracting 2 from 1/3 the height. And this is the height. Write the volume as a function of the height. Volume as a function of the height. So, well, the volume of a cylinder is the area of the base, which is pi times the radius squared, because it's a circle, pi r squared. And the radius is 1/3 the height minus 2 squared times the height. Okay, so let me think about this. To find the domain, really, all this can be any positive number, but this has to be some positive thing. So if I think, what will make this so that it's equal to 0? I'm going to actually, because I don't see this. So I have to set it equal to 0. I'll add 2. I'll add 2. 1/3 the height equals 2. Multiply by 3 to cancel out that 1/3. And I get, oh, the height has to be at least 6. Because anything smaller than 6, 1/3 times 6 is 2, and 2 minus 2 is 0, so it's got to be bigger than 6. Anything smaller than 6, and this radius will be a negative number. Okay, let's keep going. A farmer with 2,000 meters of fencing wants to enclose a rectangular plot that borders on a river. So a river, and I'm making a rectangle there. 2,000 meters. We've done these kind of things before. I've got a width, and a length. And I know that the length plus 2 widths is got to be equal to 2,000 because that's the fencing he's got, right? Okay, you know that the area equals the length times the width. If I subtract 2w from this, I get length equals 2,000 minus 2w. Now, I make an area equation. Every time we're doing things like this, you're using this fencing or the perimeter of your shape to make an equation. You're going to solve that equation for one of the variables. I solved for L because that was easiest. And the area is equal to the length, 2,000 minus 2w, times the height, the width, which is w. And I'm going to graph that. Now, when I graph this, and I'm sorry you can't see my screen here, I'm going to graph this on Desmos. So I'm going to graph it exactly like that looks. 2,000 minus, now, oh, granted, I can't do that because it's got to be like a y equals 2000 minus 2x times x. Desmos doesn't understand that. And my graph is going to be a parabola, and I'm having to zoom way out because this goes 2000 for a side is way big, but it's going to make a really, really big area. And I get the point there of 50, and whoa, I didn't put enough zeros in here. 2000. Okay, I get the point there. 500 and 500,000. Okay, and this wants to know what's the largest area. Well, the largest area is this. See, this 500 is saying this is the width because that was my input variable. So the width is 500. This is 500, which means if I take 2000 minus 500 minus 500, I get 1000. So the largest rectangle is 1000 meters by 500 meters, but the largest area it encloses is 500 square meters. Because this point is the width and the area. See, width is down here and area is on that axis. Cool. Okay, let's look at this. The marketing department at Texas Instruments has found that when certain calculators are sold at a price of $P per unit, the number of calculators sold is given by the demand equation. Whoa, this is kind of old stuff, isn't it? Yeah. Express the revenue as a function of P. Hint, revenue equals number of calculators sold times the price. Well, revenue equals number of calculators sold. Well, that's X. X is the calculator sold times the price. And it says the price, well, this is number of calculators and this is price. Oh, you know what? Oh, check it out. Revenue is a function of P. In other words, my P is there. Well, number of calculators sold, that tells me this. It tells me X is equal to 21,000. Oops, I shouldn't have done that. Minus 150P times P. See, there's number of calculators sold, price. What unit price should be used to maximize the revenue? I'm maximizing this, so I'm going to graph this. And it's actually going to give me something that looks like that. I'm going to get another point. And the input value, the input is P, the output is revenue. So if I plot this, 21,000, 21,000 minus 150P. Oh, except it told me it doesn't like P. So I have to do X times X. I get that thing, and it gives me a point 735,000. Well, that is my input variable. That's P, and this is my revenue that I'm getting. What unit price? $70. What would the maximum revenue be? That's this number, $735,000. How many calculators are sold at this price? How many calculators are sold? Oh, that's X. X is equal to 21,000 minus 150 times the price of 75. So that's I'm putting up my calculator. 21,000. 21,000 minus 150 times 75 gives me 97.50. Okay. Last thing. Bark. I need to buy bark landscaping. I have 4 flower beds measuring 80 by 10. 80 by 10. So this has an area of 800. I'm looking ahead. 3 by 12. 3 by 12, which means its area is 36 square feet. 10 by 2. 10 by 2. 10 by 2, that's going to be 20 square feet. And 3 by 22. 3 by 22. That gives me 66 square feet. Okay, it needs to be 6 inches deep. You can buy it. Okay, so timeout. So I've got all these areas, and now I'm looking ahead. I'm buying bark. We've seen problems like this, right? I'm pretty sure I'm going to have to find the volume of the bark to do that. But let me read the whole problem again. The bark needs to be 6 inches deep. You can buy it in the bag for $6.25, which covers 2 cubic feet, or in bulk for $60, which covers 1 cubic yard, which is the least expensive way to purchase bark. Show your work. Okay, so I first need to figure out how much bark I've got. Well, I've got these 4 flower beds, and I figured out that area is 800 plus 36 plus 20 times 66. So, or 800 plus 36 plus 20 plus 66. That means I've got 922 square feet total area, and it's going to be 6 inches deep. Well, 6 inches feet, 6 inches is half a foot. So if I multiply that times 0.5, that gives me 461 cubic feet of bark. That's how much I need to buy. Now I can buy it in $6.25, or I can buy it in these bags which cover 2 cubic feet. So if I divide this by 2, that means I've got 230.5 or 231 bags. Okay, and if each bag costs $6.25, I need to multiply that by 625. That's going to cost me $1,440.63. Okay, this is with the bags. Or I can do $60, which is 1 cubic yard. Well, 1 cubic yard equals 27 cubic feet. Where that 27 came from is, you remember, if 1 yard equals 3 feet, if I cube the numbers and the units. So 1 cubed, yard cubed, 3 cubed, feet cubed. 3 cubed, that's where your 27 cubic feet is in there. So if I take this 461, so here I divided it by 2 because there were 2 cubic feet in a bag. That changed it to bag. If I take this and I divide it by 27, 461 divided by 27, that means I've got to be 17.07 yards. 17.07 yards. Well, let's make an assumption that I have to do whole yards. There are places that do that. Actually, some places will allow you to do a half a yard, but I don't know anybody that does better than that. So if I do 18 cubic yards, 18 times 60 makes $1,080 times $60. This was 230 times $6.25 a bag. 231 times 6.25. Oh, 144. Or 143, because I have to write whole bags. Dang it. Sorry, I'm bouncing back and forth. If I did this 231 times 625, that gives me 1443.75. But this still gives me 18 yards because I need a little bit more than 17. So I got to buy a whole 18 yards times $60 a yard, 10,080. Bulk is cheaper. Bulk is always cheaper. But there's the evidence for it. Okay, guys, there's that whole practice test. Good luck, and I'll see you on test day. Bye-bye.